So normally when you start, you will see a window like that, or you can click on just Splunk up here, on the Splunk up here, and you will find this part. And here we will use add data to upload our own file. So click add data, for example. And then there's different ways you can, directly send logs to the Splunk. We will not click on any of these. We will use the upload button. And in the upload, we'll first drag and drop our file here. So I will just drag the file that 5295 when 82 Sysmon. You will see it up here. This is the file, and it's included in day one. Once it's uploaded, he will allow you to click next. So, and you can see the maximum file upload size is 500 megabytes. That's for the free license. If you will buy a license with a Splunk, you can able to upload more amount of a bigger file, or you are allowed to have more than 500 megabytes of logs every day. The license is not cheap, but the app is a very good app, and it's very good for free as well. As a threat researcher or even in threat intelligence, 500 megabytes can be enough for you. Depends on what you are basically doing. So click next. It will show you like a broken data like that. That's okay. Just click next. In normal machines, you'll find like real logs up here. It will show you the logs, but because it's Windows events, it's mostly like a binary file. It's called ELF file, and it looks kind of broken like that. You might see it like this, but when you actually see the logs, you will be able to convert all of these logs from this binary to automatically into text that you can read. So don't worry about this phase. With Elasticsearch, WinLogB takes all that binary and convert it into JSON file and send it to Logstash to Elasticsearch to be able to parse. So this is the part where WinLogB works. Splunk does everything that all of these tools do together, and it basically analyzes logs. Next, you have something called host, you have something called index. You can create different indexes. We will not do that. You can have a name of the host. With Sysmon logs, it's kind of useless, but in other logs, you can create here, you can put the name of the machine that's actually these logs are related to. If you're uploading, let's say, DNS logs or any different text logs, you can write here the machine, let's say, DC lab local, for example, or any name of the machine that these logs are related to, and then move forward. Review. This is the name of the file. It's you uploaded the file. This is the file. It's a Windows event, WinEFT, which means Windows event logs. This is the name of the host. This is the name of the index, and then click submit. You will find that specifically with Sysmon logs and Windows event logs, rather than it takes the host name from what you have input, it takes the host name from inside the logs, and it kind of discovers what's the actual name of the machine that you are trying to, that actually these logs are related to. So if you click start searching.
I had a question. When you say it's upload, I mean, when it shows it's uploading to just our local server, right? It's not going to the internet.
Not to the internet. It's basically still to this IP, localhost port 8000.
Okay, so since it's just a like local personal license, it's only throttling 500 MB. This is the data, right? How much we can upload?
Yes, this is how much you can upload per day.
Per day.
Yeah, okay. Not in general, it's per day. And this is the free license. If you want to upload more than 500 megabytes per day, then you need to purchase an enterprise license. That's basically for companies.
I was thinking that it was uploading to some site, but it's only within the network. Still, if you want to upload more data, you need a enterprise license.
Yes, of
Okay.
course.
Okay.
That's how they make their money, basically. Because you can have Splunk on a company. Inside the company, you can have the storage you want, but you have to pay for Splunk.
Okay.
And here you see that this search basically is saying, so here's the how the search in Splunk looks like. The source equal this file name. So basically you can search by the file name you have uploaded, just source equal file name. If you are using a forwarder like how we have with the with Winlock Beta as we have in Elasticsearch, here you will put the name of the forwarder or the source, let's say TCP forwarder, for example, or Splunk forwarder or something like that. Then the name of the machine, as I told you, it doesn't take um, up here. It doesn't take the name of the host that I have provided. It takes another host. It basically look at the system as the Windows event logs and look and get the name of the machine out of the logs itself, and replace the host name with with the name of the actual machine. So if we delete that one, you might find the actual logs start appearing. And here the source type equal, this is the type of the logs. They call it here pre-process Windows EVT. There are different types like DNS logs, Apache logs, and stuff like that. And with these types, let's remove also the source type. With these types, basically, Splunk has a list of values, is able to extract out of these logs automatically. So let's say if the source is basically Windows event logs Sysmon, he knows what to extract out of Sysmon, and he gives you all the type like event type, imp hash, MD5. He is able to extract values out of the Sysmon logs automatically. If you upload a zlog, for example, he will know what exactly he needs to extract out of these logs, and he will allow you to directly search for them. Um, so here you upload a Sysmon event, Sysmon EVTX, and here he automatically detects the name of the host. This is the name of the actual machine that has been that we are actually working at, which is Win82 dot Lake Lake State Bank dot local. The source is this the file, and the source type is Windows Event Log Microsoft Windows Sysmon operational. So it's a Sysmon logs, and from that he was able to do everything and able to detect different codes as well. So far, any question?
So it's like using is it like using AI to I guess to categorize the key values or
Not AI. He just understands. He just look at the logs, maybe a little bit of AI, but it's just a kind of he see the logs and he understands what the type of this logs based on the arguments it takes, based on like if it's a based on the structure of these logs, he maybe run rejects on them until one rejects like matches and say, oh, this is basically the log that looks like Zeke logs, or whatever the way he detected, maybe AI, maybe something else. He detect the type of logs, and from there, he is able to manage completely with everything.
Mhm.
And you can manually decide which type of logs you want to use. So you can tell him that the source is basically a DNS logs, or this is Zeke logs, or this is something else. For us, we used pre-process Windows AVT logs. This is what the source we use or the type we use. And pre-process means this is you will need to process them and then extract the source from there. And inside the log itself in Windows event logs, you can see that the log name is being written here. So he can just detect the log name, and from there he will know what the data will be and what he needs to extract. Make sense?
yes, yeah, it makes sense. So in your experience, very quickly, in your experience, does it ever get it wrong where you have to maybe like let's say it detects it as Apache logs, but you may have to change it to what it actually is?
Yes. If the Splunk detection is not correct, you can change it in the part when we were uploading the file itself. You can tell him, no, I want it to this as a DNS logs, and he will manage it as DNS logs, and he will give you like a preview of how the logs look like and so on.
Okay, thank you.
No problem. So here we have the logs, and here we knew that the attacker basically was send a malicious document with a macro, and this macro executed, this macro executed, let's say, an application or connected to the internet or did something. So what we're going to need to know is that first we'll need to see what are the events we need to look at to be able to detect such attack. So I have my computer is a bit slow now, so I will not open the camera. If you see me opening, closing the camera is also because the computer gets a little bit slow. So the scenario, as we said, that the attack scenario is the attacker send a malicious document with a macro asking the victim to enable it. Once enabled, the victim gets infected, and we have Sysmon logs to investigate further. So this is the Sysmon events. And to investigate something like that, we need to see, okay, we have a Word document that did something malicious. What malicious thing it could have done? We have three options, right? It can create a new it could have created a new process, let's say opened a new application or something like that. Maybe created like run the malware, like drop the malware and then executed it. So we might see a process create. We might see a file creation. So basically drop the malware on the disk. So we might see a file creation of a file on disk that is in temp or application data, and it's basically malware.exe, for example. We might see a network connection to the malware IP. So we will look for any of these events. Will look for the WinWord as a parent process or as a main process, and we'll see what actually had happened. Make sense?
Yeah.
Also, rather than the file creation time changed, we can check the file create itself with 11, and this is basically the type of events. And if you are threat hunting, let's say this has actually not happened. This is the hypothesis you have in your hunting. So let's say this is a hypothesis you have, not a real thing that had happened. You have a hypothesis, attacker sent a malicious document to the macro and asked the victim to enable it, and actually he enabled the macro and something had happened. How are you going to detect that? Well, I will assume that WinWord.exe has opened. WinWord.exe is the Microsoft Word application. And I will assume that WinWord has dropped the file. So that's file create 11, or has executed an application, which means event code ID with 1, or communicated to the internet to a website that's different from Microsoft websites, which is the network communication 3. Makes sense? So this is how you're going to think about hunting. When you're hunting, this is a hypothesis, and this is basically your map of what options you have, and then you're gonna search inside of them. Make sense?
Yeah. So one question for the Sysmon events. I know you thoroughly explain each category, but it's like, is there a slide where the definition breaks down the category of what you just stated, on the session?
Sorry, again, that question?
Yeah. So for each category, for example, the Sysmon, like the invit ID 0, process create 1, you thoroughly, some minutes ago, you thoroughly gave an explanation of each of them, of what they mean and how an attacker can utilize each category. I was asking uh on the slides that you created, is there a breakdown of each category by definition as you explained, just so we can kind of like get like the use of like the understanding of it?
I mean, like in the slides, an explanation for each one of them.
Yes. Yeah.
Actually, I don't, but I have the file. I will look for it. It's a kind of a cheat sheet for Sysmon. It includes everyone with a little bit of explanation and as well what exactly you can look at. Once I found that file, I will provide it to you guys.
Okay. Thank you.
And also, Dylan is saying Windows internals will help you massively. Joshua, part one. Yeah, it will do how. And in general, if the name like process create means a process has been executed, right? File creation time changed means a file name, the creation time or the date where it's being this is basically a kind of technique the malware used to hide the details, that they can change the creation time for a file. So they can say, well, this file hasn't created yesterday, it has been created 5 years ago. So the forensics guys can skip that file and think that this has appeared with the system, for example, right? That can actually be done by the malware. You can change when the file has been created, change the date if you do the file properties. Network connection is network connection, which application connects which website, right? You can ignore the Sysmon stuff. Process terminated any application that has been closed or exit. Driver loaded, it's a driver. Image loaded can represent a library that has been loaded. If this stuff, you will have also a recording of all this session, so you can also use that for you as an explanation. And I will do find where's this Sysmon cheat sheet if I can. And provide it to you guys. Is that answers your question?
Yeah. Thank you so much.
No problem. I will actually take a very fast look if I have it easy access. If not, then no.
Amar, just a quick one, yeah?
Sure.
Oh, when you run Splunk on the file that we've just had, it shows up with two things. There's event code and event type.
Yes.
So which one is the event ID, or is that the wrong
The
thing?
event ID is the event code.
Event code, okay.
Yes.
Thank you.
No problem. Yeah. So let's continue. I couldn't find it now, the Sysmon cheat sheet, but once I find it, I will share it with you guys. Probably today or after the training, I will share it with you, and it will be like a log file, like a kind of PDF file with each one of these logs and what exactly you can find, and probably a description of it too. So here we will say, well, we have this machine, and we're assuming that, or it's actually happened, that winword has been executed. So let's search with winword.exe and see if we find anything. As you see, the good thing about the main difference between Splunk and Elasticsearch is this one thing. Splunk does not rely on JSON data. It actually searches directly inside the whole log file as a text. And as well, you can search inside the parameters of it. So it has both options. The full log file that you can search with any text inside, and as well it has the extracted parameters. So you can basically search in both, and it kind of creates a JSON file in the background with all the log is called parameter 1, and then all the other extracted parameters are after and being saved up here. And you can even create a new parameter to extract from here using regex. It's really more flexible than Elasticsearch and much easier. So here, let's say I searched just winword.exe, and he was able to just show me all the events that are related, like 45 events basically, that are related to winword, or has winword.exe in them as a parent process, as a main process. Does that make sense? Pradeep has found them, has found the events logs appear. Thank you, Pradeep. You saved my day. And with all colors too. Let me. So they are basically here on Slack for you guys. Pradeep has shared them on Slack. Did you guys see it?
Yeah. Thanks, Pradeep.
Yes, appreciate it.
Very good. So yeah, it includes so many different things up here. Let me try to take a look at them. Yeah, my computer is super slow, so I will skip looking at them for now and we'll continue with the Splunk. Do you guys still see my screen or?
Yes, we can see it.
Yeah. So, so here back to Splunk. I will close the camera because it gets really slow. So we have here different values that we see, different event codes. We have the event code 1, which means a new application has been opened. We have 11, which means files have been created. We have 13, we have 7, we have 22, we have 12. We have so many different ones. So let's look at first one. What process has been created by Winward, or what executed Winward, what actually happened? So we have Winward has been executed here, as we can see, and we can see that Winward. So let's go a little bit down or a little bit up. So basically, in this log file, it's a Sysmon log event code 1, which means it's a process create, and basically Winward has executed a run-dll application with that exact command line. So it looks like it has dropped a file called ier.dll and used run-dll, which is a Windows application, a signed Windows application, and used it to run this DLL file with this parameter, or this is the API name to execute, and basically that was the main folder was the downloads, and here you have all the information. So it looks like that I want to say, yeah, it looks like winward.exe has been able to execute another application called run-dll, and this run-dll is basically includes this file, executes that file ier.dll. So now we have winward.exe has executed another app called run-dll.exe. If we did I write run-dll 32, sorry. So if we did a search like that, winward.exe, even code equal 1, and run-dll 32.exe, we can see that it actually had happened here. Winward.exe has executed, basically has opened this malicious document and executed run-dll with this command line. So what we did in the search, inside this file, we searched for winward.exe. We found so many different event codes. We choose the event code 1, and we saw there's any process that winward.exe has actually executed. So winward is the parent process, and the process that has been executed is run-dll.exe. We saw that we have an event here that winward has executed run-dll.exe with this specific malicious DLL. Make sense so far?
Yeah.
You might find some other information like the MD5 or something like that, but because the attacker executed run-dll, the MD5 you will see up here A little bit down, the MD5 will be the MD5 for the run.dll.exe. So the SHA-1 here or the MD5 up here, it will be for run.dll. If we check them in VirusTotal, you will see that this is basically undetected and everything is fine, right? Because it's a run.dll, it's not the actual IER.dll file. What else we can do? We can go back. We just search for oneword.exe and look for any files that have been created by winword.exe, and we're gonna need to find the file that's been created, the IER. So we will go back to this events and we will search for any file created. So if there's any file has been created by winword and this file might be called IER.dll, so let's check that. So we'll go back up here, we look for the event codes. There's so many event codes, and we can see that the number 11 has 12 different files have been created by winword. There is like link.link files or different other files. So what we're gonna need to search for is basically any DLL file. So we'll search .dll. And there's none. Okay, let's say asterisk.dll. Still not. Okay, let's check we have only 12, so we can check what they are. Oh, give it time. We can say, or we can just scroll there and see different files. So we see here, this is the actual file that has been created, which is basically another copy of the .doc file and some other link files. And again, the documents, and nothing else suspicious. Okay, maybe that file hasn't been saved in our Sysmon logs. We also can work on the filtration that Sysmon can have. So basically here, you remember when we had the event code =1 and run.dll up here, we have seen run.dll is running and basically is loading this specific file, but probably somehow our Windows event logs didn't catch this file being created on the system. Maybe because we only filtered that we want .exe files and nothing else, and that maybe led to that this file is being not being recorded. Maybe, right? So we can check that and we can see, okay, that probably something need to change in our Sysmon visibility, probably, right? Or probably it's not being dropped by an event, or we can say that search for this and search for IER.dll and see if it's being created. So what I'm doing here is that I'm trying different searches and I'm seeing, do we have enough visibility? Like how this file has been created in the first time. We don't have any information how this file has been created in the first time, right? So probably we are missing a visibility here in Sysmon. We can, update our Sysmon config file and include some other stuff. So that's okay. We have searched for winword. We have seen different files, different events. Let's try to investigate more what this run.dll file was doing. So we can search for run.dll 32. run.dll 32 dll.exe. And see if there's anything that's happening with run.dll. So we run. Okay, did I do something now? Yeah, it's just loading. So there is 243 events has been done by this, 5,000, 17,000. Oh, wow. Let's try to filter out. Maybe there are different run DLL. So let's check with the IER, the DLL as well. Maybe there's multiple run DLLs has been running. Give it time. So we see only two events that are related to run DLL and IER, the DLL. So one of them, as we can see up here, is the value, the event code ID 1, and another one with the value with the event code 7, or the event ID of 7. What is the event ID of 7? If we check up here, event ID of 7 means image loaded, means a DLL has been loaded or a library has been loaded. So in this case, he's saying that the first event with code, with the code 1, that is basically WinWord when it created run DLL. But the number 7 means when run.dll.exe has executed, it also loaded the IER.dll file in the memory. So because it loaded that library, we have that event is happening up here. If we click here, we have an event that basically run.dll.exe has loaded a library called IER.dll, as you can see up here. And here, by the way, you will have lots of information about this library, including this library, MD5 hash, this library, SHA1, and also this library SHA2. So you have all the information now about this specific file, including its MD5. You can check it on VirusTotal. It's not included in VirusTotal, which is something is a bit odd about that. Maybe this malware is not very known. Maybe it's a targeted malware. That's why we don't see it on on VirusTotal. In case if you don't see a file on VirusTotal, do not try to upload it to VirusTotal, because probably the attacker is also looking at VirusTotal, see if you have ever detected his malware, and if his malware MD5 is on on VirusTotal, means that you uploaded his malware and that you have detected his malware, basically. If you're asking how I do this VirusTotal, basically I installed something called VT for browsers, VirusTotal for browsers, and I give it my public IP. I have logged in and I provided my IP. It's a public IP, it's a free IP. You can just create a username and password up there. And this is basically, you will find it in virustotal.com, this Chrome extension. And it highlights any MD5 and gives you this little button beside it to click here, and it searches for that file. So you can see, you can click on any hash and it will give you information if it finds it or not. So here we have found that this file has been created, has been loaded in run.dll, and this is basically the exact hash of that file. We can look in our database, look at VirusTotal if we find VirusTotal. If not, this is something very odd. We can even dive deeper into that and see why we don't, and so on. We can search for that exact file, see if it appears in any events, or even without the path. And this file only appears, as you can see, in these two paths. So let's try to use run.dll 32, and this time we'll look for network communication. So now we found the attacker file. We found how the attacker basically executed his it will take a bit of time. We found that WinWord has executed run.dll with a specific malware. We found that malware hash, so we have an IOC. Now we can scan our systems with this hash of the IER to DLL file hash because we have it. Now we have an IOC, we have the file that's being executed, and we are confident that WinWord should not execute run DLL and should not run DLL should not load IER to DLL file and give it this random parameter. So we have lots of information up here. One information we are missing is IER as a DLL, does it connect to any malicious IP, or one DLL as a process, does it connect to any malicious domain or IP? We can look for events, and we can look for any events with the ID 3. If you see up here, network communication is happening on the event ID number 3. So we can try to check any network communication, sorry, any network communication that's happening by the run DLL to see if it connects to the attacker so we can get its own IP. So we can see that there is lots of events has been created by run DLL. It looks like it's connecting to the internet a lot. We can check that. So run DLL.exe even code 3. And let's see what are type of events. We will see what type of domains, IPs. There might be some are whitelisted and some others will be blacklisted events. So once we run that, we can look for any domain or any IP. We can show all the lines and see if what IP is trying to connect to. Here's like a local IP to another local IP, so we can skip that. And another local IP. So let's say we can try to filter out. So this is basically actually not a local IP. That's that's not a local IP. That's basically a global IP. That's basically the IP is trying to connect to. And that's basically something, right? We can use it to filter out our events, or basically see if it's like this is basically we can check this IP in VirusTotal or something, see that IP. We can I don't think we can search here, but we can go to VirusTotal and check if VirusTotal knows that IP or not. Is it malicious or not? Has been used before or not in any malicious events? And we can see that this IP has been used in phishing. It's a malware, it's malicious. So we found the IP of basically the attacker. We're able to extract an IP, and you'll be surprised how many connections are being done to that IP. So we have here 53,000 events, and if we write that IP, well, it's only 50, no, 3,000, 20,000, 42,000, 54. So basically, most of the internet communication is actually going to that IP. So many communications actually going to that IP, and we're able to detect that IP, and basically we're able to detect the attacker IP and understand what exactly is happening there. So that's basically our own investigation. We're able to extract what's actually happening after WinWord, what's the application that's running, the DLL file, the hash of that file, the IP of that file. Now we can take these IOCs and scan all the computers and all our logs if they have seen that IP, if they have seen that file name, or they have seen that hash, and basically detect if there's any other machines that have been infected. And with that, we can basically, even for the document itself, and with that we can detect how many machines have been infected, and we can start our incident response process. Any question about that?
Amar, just confirm. So you said the IP address we searched for the CNC. So when we follow it, we can see the communication that has happened between the attacker and the infected machines. Is that it?
Yes. The IP of the attacker and run.dll.exe, which is basically that's running the malware, is connecting to that IP. So this IP looks like it's being used as the attacker CNC, And as well, we checked it on VirusTotal when we saw that there are 13 different sources that say this IP has been used in phishing, has been used in virus malware attacks.
Yeah, thank you.
No problem. Any question, guys, so far?
Anna,
Yes.
when we're conducting this log analysis, right, are there a list of questions we need to kind of fill, like satisfy, to like help us in our investigation?
Yes. So we started first with the hypothesis. Then we started diving deeper into proving that hypothesis. It's proof that actually we have a version of WinWord that's executing a malicious file. Now our questions are more about data mining, like getting more information. Like, okay, can we get the hash of that file? Does it have any internet communication? Does it do something malicious? What exactly this is doing? Do you hear me, Clarence? Do you guys hear me well?
Yeah, your voice is fine for me.
Okay. So, so basically, that's what is actually what we are doing. We are diving deep into the data. We are doing data mining, and we're trying to detect the IP. We are trying to detect the like what's exactly is happening on the system, and we are trying to understand what's happening in every single step. Make sense?
Yeah, could you repeat the part when you were talking about hashing? I think there's some feedback, and we really didn't hear it.
How we brought the hash?
You, so when I'm sorry, what was the gentleman's name? Dylan asked a question about what thought process. I don't know exactly how you asked it, but to go about doing our investigation, there is a part where I didn't hear. There's a lot of feedback.
Okay. So basically, there is two parts that I was doing, and the first part was the threat hunting part. I put a hypothesis, as I'm assuming that the attacker has sent a malicious document with a macro and asking the victim to enable it. Once enabled, the victim got infected and so on. I want to prove that hypothesis. So the first question is how I can scan my logs to make sure that this to detect something like this. So I said, okay, I would assume that because I have the Sysmon events, I can assume that WinWord.exe has executed a malicious application or has dropped a malicious file. So that's basically my first hypothesis. And this hypothesis, basically, I looked for process create from WinWord to a file, and I saw that process, so WinWord has basically created a run.dll file. So created a new process or executed run.dll with a malicious file. So I saw that, oh, that looks like something suspicious. So my hypothesis has been proved true. Now my threat hunting questions is done. Now I proved my hypothesis is true. Now the next step is to investigate the incident. Now I have different questions. Okay, does it execute a malicious file? So what this malicious file is doing? What is the hash of this file? So I can scan all the systems. What's the IOCs? The hash, IP, all of this is the IOC. So first I want to extract the IOCs so I can understand the scope of the incident. How many machines have been infected by this malware? So the first thing I did is that I searched for the hash of the dropped file, the IER.dll, and I found it in. I couldn't find it in the file create. I couldn't find an event file create for the IER.dll, but I found when run.dll tried to load that DLL, and I saw it in the image loaded event. So I saw that this DLL has been loaded with the image load event and includes its a hash and includes more information about this DLL. So I was able to take this the hash and able to use that as my first IOC. And the file name as well, IER.dll. So this is the first two IOCs. Then I said, okay, can I get an IP as well? So now I will look for run.dll connecting to any IP, and I found the IP that we already have. here, which is this IP that this RunDLL is trying to connect to. So now I found also something else. So I found now the malware hash and the malware IP and the malware file name, which is IR.dll. Now what I'm going to do is that I will search through the whole organization for any other machines that has any of these, this IP, this this file name or this file hash, right? Now I have this information. I will scan the whole, I will scan all the logs I have. I will scan all the machines searching for this file name or file hash or IP. Make sense? So this is
So,
instant response questions.
so would you say the end goal is to find the deliverables, which are the file name, the file hash, and the IP?
This is the first phase. So the first phase, I want to collect IOC so I know how many machines are infected. And then I can investigate these machines more to find this malicious document, find the IR, the DLL, analyze these files, understand what the attacker is trying to do, what commands he executed, how it started first time, what's the phishing email look like. So I will start to answer more questions. But the first thing is that I want to find the scope of the attack. How many machines have been infected? So once I know how many machines are infected, I will contain all of them, isolate them from the network so the attacker cannot connect to other machines and, stop the attack a little bit. Now I stop this attack. Now I want to investigate further what had happened to these machines. Did the attacker steal accounts? Did he access file shares? Did he basically install a backdoor? Did he install another backdoor? Did he access other networks? Did he use other vulnerabilities? Did he become an administrator in this machine? Or how did he come from? How this malicious document looked like? What exactly has been running? What's the IP? What's the email looked like? How this email be sent from? All of these questions I will start to answer. Why my security controls? Why my spam filter didn't trigger on this email? Why it passed the spam filter? Why the employees didn't detect this in the first place? And start answering these questions one by one. You remember the playbook we used to look at, the syntax IR phishing playbook? We will start playing that playbook step by step until we basically respond to the whole incident.
Okay.
Now, for example, I will say, well, I know now that rundll.exe has been running and there's so many events. Let's see if rundll has executed any other commands on the CMD. So rundll.exe event code ID equal 1, and you'll see if there's any execution of other commands has run on the system. So I can see here rundll has executed CMD, and then it copied another file called core.bat to a file share. So this is the second thing I saw. So now, after I found the file hash, the IP, and everything, now I want to see if there's any other events or there's any other commands this rundll has executed on the system. Did it execute any CMD commands? Did it create any other process? Did it download another file? Did it basically run a second stage backdoor? Did it try to infect other machines on the network? So now I'm investigating further. After I collected the IOCs, this is the first phase, and I know the machines have been infected. Now I will investigate further to see if there's any other activities that happen, if it's spread through network and stuff like that. Now I'm searching for rundll32, and I'm looking for if there's any other application or any other command this rundll has actually executed on the system. Make sense so far?
Yeah.
Yes.
Perfect. So now I'm searching rundll, and now event code 1. And I saw there's 18 events where rundll has appeared and has executed an application. So let's see. One of them, if we looked at it, we see that it executed cmd.exe, and the command line is exactly like that. cmd/cmd.exe/c copy core.bat. So there's a file has been created called core.bat to that path, which is this path is basically on the file share. So it's basically trying to copy a file to the file share. Very interesting. Another command we saw that he was trying to copy core.dll to the file share. So it's copying core.bat and core.dll. Looks like core.bat executes core.dll. We need to get that file if we can. And then we saw another copy to the file share, probably copying to different file shares, and we can see more of this copy, and we can see more events is happening here. Copy the .core is trying to copy them to all the machines basically. So basically he's writing all the IPs of different machines and trying to copy that file to them, to their C. This is the same machine. And if we go farther, we can go farther and farther and see if there's any other events that's happening. We can say, okay, we don't want to see this information. Sorry. Let's ignore any core.dll or any core.bat events. We can say not core.dll and not core.bat, for example. And not. So we found 8 events up here that doesn't include core.bat or core.dll. This one is basically dir, this share. So basically it's trying to look at the file shares, see what's actually happening there. Dir is directory list. So basically, and this means he's looking at that machine. 10 dot is a local IP. I mean a network IP. It's like an IP inside the organization. They call it private IPs. Any 10 dot something is a private IP, means it's only being used inside organizations and not a public IP to the internet. And basically he's looking at one of the machines inside the organization, and he's trying to look at the C, basically at the C drive, see if there's any files are included there, what are the files, what he can steal probably, right? We can see other commands, other dirs, maybe the same IP up here. So probably the same command has been executed multiple times. This hero is running 0.exe on that IP, DC1, and he's giving it different, basically it's trying to log in with the administrator up here on that lake. So it's basically trying to access the DC1 machine on that domain with the username administrator, and he's trying to run PowerShell there. As 0.exe, we don't know what's 0.exe, but we can investigate further if we can find the 0.exe hash and see what that file is. So that's another command we have found, right? So we can look for that a bit later. Let's see the other commands. You see netgroup /domain, so it's trying to see basically the different groups, Active Directory groups that's running on the system. We can see as well other commands up here like netview. All of this is looking through the domain lists. It's trying to run another malware basically on this IP, which is program data /gas.exe, and you can see different malwares have been dropped everywhere. Now our job is trying to get the and he's copying that gas again to the file share. So it looks like he's copying that file and he's executing it. So now we have seen different commands being running up here, and we can see this is the normal execution of run.dll. This is when WinWord executed run.dll with the IER. So this is the first event, and now we can see all the files are being copied to different file shares, different systems. The commands have been executed, and now we can search for 0.exe and trying to get 0.exe file hash. So we can search 0.exe event code, for example, equal 1, and we can see if we can get 0.exe file hash. So here we have 0.exe has been executed, and this is the file hash for 0.exe, and we can check it in VirusTotal, and we can see it's a malware. And Also, if you look at it, you can see it's an exploit. Some people say it's an exploit. Some people say it's a hacking tool. It's an exploit for this CVE, specific CVE. You can start looking, what is this CVE? What does it mean? Probably it's basically a vulnerability. I think it's zero login, I believe. So this is a privilege escalation vulnerability that's being used on NetLogin secure communication to a domain controller. So basically it's using this vulnerability, and it's a very critical vulnerability. So now you know more information about the incident. So he used the zero login CVE, or he used this vulnerability with this CVE. Now you need to talk with the vulnerability management team and tell them that this vulnerability needs to be patched. It has been abused in our organization, and we need to always patch any critical vulnerability like this one. This is like super critical. Like you have to, like it's 10, like score 10. That means it's the most critical vulnerability you can ever have, right? And basically he abused that vulnerability up here with 0.exe, as you can see. We can also search for gas.exe and see what's that malware as well. And gas.exe, you can see it's being executed here. Unfortunately, we don't have the exact file, the exact hash for that file. We don't have it here, but if we looked at the event logs for that IP, we might find gas.exe there as well. Or we can remove that and see if we have any file creation. Are you guys following with me, or you are completely lost? I'm going fast.
I'm good.
Amar?
Yes?
I'm following along with you. I'm totally fine. But I just have a question, right?
Sure.
Do you know when you said, when you went into that log and said you couldn't find the hash of the gas exe, right?
Yeah.
But like, didn't it display it like with the SHA-5, like MD5? Isn't that the hash of gas exe?
So in MD5, there are multiple types of hashes. We'll talk about it a bit later, but I'll explain it to you now. There is file hash is kind of an algorithm that helps you to kind of have like an ID, a unique ID for each file is being created. And basically, this hash, like let's say there is multiple types of hashes. There's MD5, SHA-1, SHA-2. All of these are basically a unique identifier for that file. It's hard to find the same MD5, like two files with the same MD5, or two files with the same file size and the same MD5. That's like almost impossible, right? So it did happen a little bit with MD5, but SHA-1 and SHA-2 still not happen. So that's why people sometimes use SHA-1 and SHA-2.
I don't understand what's the difference between SHA-1, MD5, SHA-256. I know the hashes and different types of hashes, but I don't understand the difference.
The difference you can see in the length. Like MD5 is the shortest one, SHA-1 is a bit longer, and SHA-2 is longer and longer. The algorithm is different how each hash is generated, but the main difference is if you have a very long hash like that, or a very long ID for a file like that, it's less likely you'll have two files have the same ID. While you have an MD5 is a bit shorter, that means that could really happen that two files with the same file size have the same MD5 hash. So because it's a bit shorter, so as an identification, it's less unique than the SHA-2, for example. That's basically the main difference. But for you, for most of us, we don't really see a difference between them. You can check any one of them, and they're basically all are the same for you. But they are all different from MHash. MHash is a completely separate thing. We'll describe it later. But here, if you look at this hash, you'll find that it's basically a clean one because it's the hash of CMD. This is basically the application has been executed. We want the hash for gas.exe. So we'll look through if there is anything that has the hash of gas.exe, And guess what? We have here an event. If we look at it, we can see that.
Yeah, I have a
Yeah.
hello. Yeah. Quick question. Because I want to make sure I'm actually caught up. So when there's an executable that creates a hash, and then you're verifying if that hash is, you know, on the virus tool or not, or because I'm not understanding that context.
So basically, when Sysmon has the ability that when any application gets executed, it generates this file hash. This is a unique ID for that file that should not appear in any other file except that one. So this is a very unique hash or unique ID for that file. Is it okay so far?
Yes.
And it's a standard way to generate that. So if you by any chance somebody else in Japan has the same file, he will generate the exact same ID for the exact same file. If it says the exact same file, it will be the exact same ID. So now all of you have the exact same ID representing the same file. Now you can easily talk about this file. Do you have that file? I have a file with that hash or that ID. Oh, I have the file with I have the same ID. So we basically have the same file. Now this is a way to communicate about files rather than sending the file to each other all the time. We just send the ID and the ID represents the file, right? So far so good?
Yes.
Now, VirusTotal 2, somebody probably have seen that file and uploaded that file to VirusTotal. VirusTotal is a website that scans any file against so many antiviruses, and it contains a massive library of files. And as well, it generates the hash, so you can say, oh, VirusTotal, do you have the same file? And I give them the file ID or this file hash. And VirusTotal scan its library and see, oh, I actually saw that file before. And actually, when I scanned that file, it was there was 10 antiviruses that saw it's a malware. How did we communicate about this file? I give him the exact hash, and because he generated the same hash for the same file, we're able to communicate about the same file between us and VirusTotal. And he told me that VirusTotal told me that this hash has been used in a malicious, or this file has been used in malicious activities. Make sense?
Okay. Yeah. Now I understand.
Very good.
Okay. Thank you.
No problem. But when you when basically you create a process with CMD, this hash in front of you is the hash for CMD, not the hash of the gas.exe that you see up here. Unfortunately, we don't have the hash in our logs up here. Probably we'll need logs from this infected machine to know where gas.exe has been executed. And for now, we don't have, unfortunately, this logs for gas.exe. That's okay. We have now the hash for, we're also not sure if we have the hash for core.dll. We can search for that as well. If we ever have the hash for core.dll, we can search through the logs, and unfortunately we only have the command where he copied that file to a specific IP. So we need to go and grab the Sysmon logs for that machine to get the hash of core.dll and see if we're executing any other commands. But now we have quite an imagination of how the attack looked like, right? If we can go to a whiteboard, we have seen that there is winword.exe or Microsoft Word to a malicious document, right? And this file has basically executed run.dll 32.exe with a file called IER.dll and with some parameters, right? Some random stuff. Now that's we know for a fact. And we have the hash for IER.dll. So far, so good?
Yes.
We know that IER has executed so many different commands up here. And these commands are, let's say, connected to an IP that's 190 dot something. We have the IP. We know that it executed cmd.exe/c, and it executed basically or copy and executed on another machine the malware 0.exe and executed that on the DC1, which is basically an exploit called zero login, I believe. Login. And now we have that. And we know as well that it also copied another DLL called core.dll, which we still don't have the hash, and core.bat, and executed them on another machine, right? And we can log into this machine and find these two files and find their hash and so on. We also saw that this run.dll also executed gas gas.exe on also another machine, right? And we still don't have the hash for that too. Now we know all of that, and we also know that it also tried to do some reconnaissance or discovery on different Active Directories. It used net commands to basically get to know ED users, domain or ED groups, and so on, right? So basically use that for more reconnaissance around the machines that are around the Active Directory on that company. Dylan, you want to say something?
Yeah, Amr. So net commands, are they like, do they come from like a tool? Like
Yeah.
what are, yeah.
So net commands basically are Windows tools. Net.exe is a Windows tool. It's available by default. And this tool basically provides the ability to investigate further anything related to Active Directory. So you can use it to get list of users, to create a new user, to list of groups in the Active Directory, and so on.
Right. So how does the attacker use, what tool would the attacker use to perform net commands?
It is a tool itself. It's net.exe. It's itself is a tool.
Oh, sure. Okay.
And it takes arguments like net create user or net do something, you know. So it's a net.exe and it does some other stuff.
Sure. Thanks.
No problem. So that's basically the map of the whole attack that we were able to discover through our logs in Splunk. I will save that just for.
I have one quick question. So the scenario was that the attacker uploaded, used a malicious document to perform an attack. Why the assumption? Okay, let me not use that. Why is it that Windward? Sorry, I'm trying to figure out how to ask this. So I got lost when how we came to the the conclusion that Windward, which is Microsoft Word, was the document that we used.
Okay, so that's basically an assumption. We know that Microsoft Word as an executable is called winword.exe. That's what we know for a fact. So if we want to say somebody has used Microsoft Word to open a malicious document, we are meaning that it's a winword.exe. That's for sure.
So we went looking for it because it could. Okay, yeah, because that's where I was lost, because I thought maybe like, okay, if it's a malicious document, it could be Excel or a text file.
So this is, let's say, this is our assumption. It might be the assumption that it's an XML file, or it might be a PowerPoint slides. PowerPoint do have malicious macros too, So It's an assumption. So in threat hunting, it's basically an assumption, and our assumption was actually correct, that we actually saw that there is a winword.exe opening a malicious document. So our assumption was an employee has received a malicious Word document. Let me clarify, malicious Word document, and this malicious Word document has executed a malware or had a macro, and this macro did something malicious.
Okay. So that goes back to what you stated, that we have to create our hypothesis, then we go looking for the hypothesis, and if it doesn't lead us, down a rabbit hole, then our hypothesis is probably not true. So we, keep going until we can prove our hypothesis.
Exactly. If
Okay.
we couldn't prove it, that's fine. We can create a signature now, a detection rule, that when you see a winword executing any application except specific applications, or executing run-dll, cmd, or net commands, or executing anything not in program files or system32, then give us an alert, for example. Right? This is our detection rule we will create later on. If there was no incident, or there was, maybe we'll expand that to say it's WinWord or Excel or PowerPoint or let's say Outlook, right? So we will, iterate that later on if we want to include other malicious documents too.
Okay. Okay, perfect. I understand.
Very good.
Yeah,
So,
I had a question. Are we able to establish that all these executables, gas, CORD, were downloaded from 190, or we don't know right now?
sorry?
All these executable, malicious executable, gas, CORD.dll, are we able to establish from this that it got downloaded from 190, that you we don't know right now? Okay.
This is not really yet as a fact. By the way, we're only looking at Sysmon logs. So maybe HTTP logs from Zeek can tell us more information, right? Can tell us where these files have been downloaded from, and can give us also the hash. Zeek logs can also provide us with the hash of the downloaded file. So we can basically, if we don't know where gas looks like or where it came from, it might be already on the, let's say, we might find it from the download from Zeek logs and find the hash from there. So we are here using one logs, but in general, when you are an incident response, you will use so many different logs and so many different information you can find from different ways. So let's say we only found an IP of the attacker, we didn't find the port, and we didn't find if this IP represents a malicious domain. So we can look at the DNS logs, look for that, look at the Zeek logs if this IP has been used in any network communication, and that will help us to understand more.
Okay, thank you.
No problem. So that's basically the attack. Back to the slides. We still have a lot to cover, by the way. And that's basically this part when it returns to Sysmon events.